Joseph?
I'm fine, and you?
So, okay. Tomorrow I have give you homework how you can draw the next block. Did you write it or not?
Yes, I can share my screen.
Just give me 1 second.
Uh,
Let me give you rights.
Okay,
Okay, now you can share your screen.
okay. This is that I obtained.
Okay, great, great. I think you have created a good mesh. Okay. So this is the scare inside. Now the only thing is just we want to remove the Z axis. We want this thing only in 2D in X direction and Y direction, not in Z direction. So can you remove Z direction and add only 0.1, 0.1 along Z axis in your block mesh?
Uh, I don't understand very well what it. You want to that I remove
Okay,
all the
let
zeros?
me tell you. Let me tell you. Now close this paraview,
Okay.
minimize it, open your Ubuntu terminal, open block mesh. Open block mesh, press capitally.
Okay.
Okay, now just change the direction of Z. You can see where in Z direction the number are written as 3, change all of them to 0.1, okay? In vertices.
Yes, that I can change the simple grade in
No,
zero
no, no,
point.
no, 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 in vertices. You see the vertices, total vertices are 25. Vertices,
Uh-huh.
not blocks.
Okay, that I
No,
change
no,
for.
no, 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 let me give you rights and tell you which thing I am asking. No, it says please accept them.
Okay.
Okay. No, this is thing which I am asking. Now let's it will go up. Now you can see. Yeah, there. This is from a 3 vertex. Change this 3 to 0.1. 0.1.
All in Z axis I going to change.
Okay, now I'm just giving. And now next one.
Uh-huh. All that all the number 3 I change for 0.1.
What? Please come. I don't understand what is going on here. Okay, now you change this 3 to 0.1. Okay, I'm just giving you control back. I think you have
Okay.
put an E.
What happens? I don't understand. Oh, why is that doing that? I don't understand.
I will tell you at the end. Let us change.
Yes, sometimes past this, I don't know why.
Okay.
Maybe the what will be that I don't know. What happened? Zero, let's see. Why is happening that? I don't know the.
Press escape from your keyboard.
Okay, yeah, escape.
Now shift colon WQ.
But I don't finish to change
First of all,
the.
press shift colon WQ, then you will change. First of all, press escape, shift colon WQ. WQ, enter. Now open once again BAM block my stick. Enter. Press capital E and enter. Now press I. Okay, now you can change.
Now yes. Maybe. Sorry. That's
Okay,
all.
press escape, shift colon WQ and then run your block mesh.
Sorry.
Go back to one directory. Enter. You have make a mistake. Where? Open your block mesh once again. Open system directory. Open block mesh. Capital E and enter. Just little go up. More. Up. Yes, there is your mistake. You have entered two brackets here at vertex number 11. At vertex number
Yeah,
11. Yeah.
yes.
Remove this. Press I from your keyboard. Remove this thing. Yes. Press I from your keyboard. First of all, if you press I from your keyboard, then you are able to change. If you are not going to press I from your keyboard, then you are not able to change. Okay.
Okay, yes.
Okay. Now press escape, shift colon W key. Now cd dot. All right, here block mesh.
I don't know. I have this. Yep. That's one.
Okay, now can you move little? Move it little. Now I think that oh no, we have to change its number of words is longer. Close it. Close this paraview.
Okay.
Close this. Open your Ubuntu terminal. Open block mesh. Open block mesh. Capital E and enter. Now you can see in hexa blocking, change along Y Z axis, change this 50 to 1. You see 50, 50, 50, and in a long Z
Yes.
direction, change this 50 to 1 in all blocks. Okay.
Okay.
Not a long x-axis, not a long x-axis, a long y-axis. You have
Only y-axis. Okay, okay.
along z-axis. Only along z-axis. Yes. Only, not y. Only along z-axis. Yes. Change this to 1. Same with the next one. Good. Same with the next one. Okay. Same with the next one. Okay. Same with the next one. Now press escape, shift, colon WQ. Now press CD dot dot. Enter ls here. Now write block mesh.
Okay.
Block mesh and then enter. Okay. Copy and paste files at desktop.
Yeah. Explore. Okay.
Okay. Open ParaView.
Yeah, okay. Okay.
Now open with block mesh. Surface with edges. Okay. Okay, I think good. Now we are going with the boundary conditions. Okay. Anything else we need? Okay, this is not a good mesh right now, but we will still go to for a boundary condition. We can define certain things after this thing. Okay. Now, first of all, we are going to for boundary conditions. So, in order to assign boundary condition, we have to know the names of the plane. Okay. First of all, give me this thing. Request access.
Okay.
Okay, now let me just. Okay. Now this is our 2D. Now first, what is the name of the box?
Maybe the refining.
Yes, this one. The blocks are not. Okay, now let us go through from these blocks. Okay, now back to the request.
I close that.
Yes, close this ParaView. Close this ParaView. Open your machine Ubuntu terminal. Open this mesh. Okay, first of all, close your terminal right now.
I gonna close that.
Okay, close it right now. Close your Ubuntu terminal right now. And stop your sharing screen right now. Okay, now let me share my screen.
Okay.
Can you see my screen?
Yes, I can see Walid.
Okay, now good. Let me just give you how we can assign a boundary condition in our case. Okay. Okay, so your case was the simple form. I was right. Okay, now let me open the file simple form for you. CD tutorials, tutorials, incompressible, uh, simple form, and there we have pits daily, pits, PIG, pits daily, space, forward slash, at home, college. Okay, now remove this thing now and CD. Oh, sorry. Let me remove this thing, not this CD. Because I was going that directly, I have to copy that directly. CP minus R is the command in order to copy thing. Okay, now I have copied. And now you can see on my desktop I have a file of pits daily. Okay, now I'm going to open this pits daily. CD pits
Okay.
daily ls. There we have. Let me open system directory for the ls vam log mesh. Log mesh. Okay. Now I open this thing. Now let me change this for you. Now the first of all, the scale in this case is 1. Okay.
Mhm.
And let me remove these things from here. Edge boundaries. Okay. Let me move them. Okay. So now let me move the blocks for you. So okay. So this is our case. So our direction along x will be 1, along y will be 0, along z will be 0. This is point number 1. Okay, this is along x first point will be 0 0. Okay, let me assign this thing is 0 0 0 0 1 0 and 0. Okay, and this is the point number second, and the third point will be 1 1 0, and this is point number Okay. This is
Okay.
point along one along x it will be 0, along x it will be positive, and this is 0. So this is our block starting from no let I have not given exact time. This is our block number 0. This is block number 1. This is block number 2. This is block number 3. Okay, now what about the next point? The next point is 0, 0, 0.1. Okay. Now let me close this, and this is our block number 4. Now you can see 0, 1, 0, 0.1 bracket, and this is point number 5. Now this will be our point 1, 1, and this is point our 0.1, and this is point number 6. Okay, this is our last point. This means 0, 1, 0.1 bracket is closed, and this is our bracket number 7. Okay. Now let me close here and write here shift colon WQ. Sorry, first of all, I have to write a block and then I have to run. Okay, this is our block hex. This is our block hexa bracket. There is a sign. Okay, first one is 0, second one is 1, third one is 2, and fourth one is 3, and the next one is 4, 5, 6. And 7, then close, then brackets along 100, 50, and 1. Okay, then simple grading, SIMPL is simple, GRADIANT grading, bracket 1, 1, and space 1, then close. Okay, now escape, shift colon WQ, shift colon WQ. Now let me go to back to one directory and write here block mesh and check whether it have any error or not. No, it is written in a good form. Now ls here. Now let me tell you. Okay, now it is a good. Now let me stop my sharing screen and share a whiteboard for you. Okay.
Okay.
This is the whiteboard. Okay. Can you see the whiteboard?
Yes, yes, I can see.
Okay. Now this is our block like this. Okay. And let me draw another square for you, starting from there and up to going like this. Okay, and this is a straight line. This will be a black, starting from this point to this. Okay, and there will be another black line starting from this to this. And another black line starting from these vertices, and there is another starting from this to this point. Okay. Acha. Okay, this is our vertex number 0. Let me write text here. This is vertex number 0. Okay, and this is vertex number 1. This is vertex number, and this is vertex number 2, and this is vertex number 3. Okay, and this is our vertex number 4, and this is vertex number 5, and this is vertex number 6, and this is vertex number 7. Okay, so these all are the vertices. What about our inlet? The name of the inlet, let me write here. This is this first plane is our inlet point. Let me write this thing as a green one. This full plane, okay, is our inlet. Okay,
Okay.
this green plane is our inlet. Let me draw color it to the, okay.
Yes.
This is our inlet. Let me assign the name for inlet and write here inlet. INLET. The what are the its name? Its name are 0, 4, 7, and 3. 0, 4, 7, and 3 are the names of my inlet.
Inlet. Inlet
This
space.
will be
Okay.
our outlet. This thing is our outlet. This thing. Okay. This will be our outlet. This plane. Okay. This plan is our outlet.
Outlet.
Now let me write here this thing here outlet. Outlet. And what are its name or its things? Its names are like let me write here. This is 1, 5, 6, and 2. Okay, this is the name of while on the front and back then. What about wall? The wall is 0. This thing, this is my lower wall and this is my upper wall. Okay, the lower wall. What about the lower wall? And the lower wall will be a yellow. This one from here and from here. This is my lower wall. Okay. Did you see this pen?
Yes, yes, in yellow.
Yes, this in yellow. This is my lower wall. Okay. Let me write
Okay.
here for you. This is lower wall. Lower wall. What about its plane? Its plane is 0, 4,
1.
5, and 1. Okay. This is my
Why
lower.
don't 0, 1, 5, 4?
Yes, you can see 1, 5 or 5, 1. There is no need any direction in this case. While when we are
There are,
building a
okay.
block, there is a direction in anti-clockwise. While in this case, there will be no any direction. You can just assign them what are your lower wall and what are your upper walls. Okay.
Okay, okay, I understand.
Okay. Now let me give this thing to blue, and this is my upper wall. Okay. This thing is okay. Let me write here for you. That is upper wall. Blue. There will be this is lower wall and that is upper wall. It will be an upper wall. And what is the upper wall? Upper wall is 3, 7, 2, and 6. Okay. Up till now, if you have any questions, you can ask me. Okay.
Okay, it's okay. No
Okay.
problem.
So these are the things which I am using here. Okay. Now this is my inlet. This is my lower wall. This is my upper wall. This is my outlet. And what about my front and back plan? The front and back presently in OpenFOAM. Let me write here what is the front plane. This will be like this one. Okay. And this is my starting from from this point to this point. This is my front plan. Okay. This thing is my front plan and this thing will be my back plan. Okay.
Okay.
Okay. This thing
You are
is
defining.
second.
Okay, okay.
Okay, now let me write here for you what are the front and back plane. Front plane, front plane. Front plane is 3, 0, 1, and 2. Okay, and
Okay.
this is my back plane. Let me write here. BACK back plane. My back plane in this case is 4, 7, and 6, and 5. These are my plane. Okay. Now these
Okay.
are the things which I am just going to write in my block mesh. Okay.
Okay.
So you are seeing my screen right now. Let me stop this thing and try to put them. And let me just take a snappy shot of this thing so I can remember it. New and put this thing at my desktop. Okay.
I see your the draw that you explained, the inlet, outlet, phone, back. You are in there?
Sorry.
You are in this screen? Or are you showing the Ubuntu terminal?
Yes, I have changed all the colors while I
Ah,
was planning.
okay, okay.
Okay. And this is my boundary condition of previous. Okay. So okay, now let me stop my screen. Okay, now I can share my screen from. Okay, now can you see my screen?
Yes, I can see.
Okay, now let me just go to here and open my system directly. Can you see my you want to terminal right
Yes,
now?
I can. Yes, yes, I see that.
Okay. CDPI gets LS CD system plus VAM block mesh. Now let me write here I. This is the first block. Now let me go to the first one. This is the first one block and block. Okay. So what about my inlet? My inlet is the point which start from this. Let me open a file for you. Where is that thing? This one. No. This one. This one. So this was the picture which we draw on our whiteboard. Okay.
Okay.
Okay. Let me just go through. Okay. So what about the inlet? Our inlet are 0, 4, and 7, 3. Let me write here 0, 4, 7, and 3. Okay. What about my outlet? My outlet is 1, 5, 1, 5, 6, and 2. What about my upper wall? My upper wall is 3, 7,
Uh-huh.
2, and 6.
And
Okay.
6.
What about my lower wall? My lower wall is 0, 4,
4,
5,
5,
and 1.
and 1.
Okay. What about my front and back line? So in this case, both are empty. So these are the boundary condition I am assigning right now. Okay, front and back line are empty. So what is the front plane? First of all, the front plane is 3,
0,
0, 1,
1, and
and
2.
2. And the second point is like
4, 7, 6, 5.
4, 7, 6, and
And
5.
5.
Let me just give them bracket to everyone. Okay. And this one to also this thing. I will not assign any bracket them. This will be bracket. And then same is the case with this one. And same
Ah,
with this one. This one. This one. mm, This one. This thing. This thing. So I think I assigned everything right now. Nothing is left behind. Okay. This is thing right good. Okay. So let me just close it and save it for you. Save shift colon W2 and cd space dot ls. Now write me here. Let me write here block mesh. Yes. Okay. Now the mesh is good. All things are clear. Now let me see in a para view whether it is good or not good. XPLORER dot exe space and dot enter. Now I see these files are present here and I'm just going to copy them and paste at my desktop. minimize and paste it here. Okay. I have pasted them at my desktop. Now I'm going to open my paraview. Okay. Now my paraview is open. And this is where my it's daily. Oh, I have not created a file x.form, so I cannot view them. Let me close this and just go back to my terminal. And this was the terminal. Okay. Now let me create here a file touch x or bits bits dot
It's the
xml. Okay. Unless now I can see here. Now let me write here xplorer dot exe space and then dot. Okay, now let me copy this splits form and I have copy this thing and paste in my Australian paste here. Okay. Okay. File open splits.form. Okay, now let me apply here. Okay, this was my geometry. And these are the okay. Let me disable here from internal mesh. Now no mesh will be there. Okay, now only enable let me inlet. So you can see this is my inlet. Okay,
yes.
I've assigned this boundary condition. And what about my outlet? This is my outlet because I have given this thing as my boundary condition. This is my outlet. And what about my upper wall? This is my upper wall. Okay, can you see? This is my upper wall, and this will be my lower wall. So this is
No.
overall block. If I want to just enable the front and back plane, I can enable them by just simply clicking at them. You can see front and back plane are also enabled. If I just
Okay.
off inlet, lower wall, outlet, and upper wall, only front and back. Now you can see these are the front and back plane. Okay.
Okay. Yes.
These are the front and back plane, so we can easily try to do assign boundary condition in OpenFOAM by just giving the name. And if we remember the name of the our vertices, which is vertex number 1, which is number 2, by giving the name of these vertex, we can easily assign boundary condition. Up till now, if you have any question, you can ask me.
No, there are not problem for now.
Okay.
But
Okay. So let me go once again from this point. Let me disable the front and back plane. Now let me enable only internal mesh. This is the internal mesh, overall mesh. You can see this is the thing, and this will be our mesh. These are the things how we can just assign boundary condition in our cases. Okay. So in your case, right now, let me just stop this thing and just go back to at terminal. So where is whiteboard? Stop here and share and white. Yeah. Okay. Now let me clear all my drawing and try to put. Okay. In your case, you have block number 1. Okay. And then you have block number 2 like this. Okay. Then you have your block number 3 like this. Okay. Then you have your next block like this. And then you have your next block like this. Okay.
okay, that's right.
So you have to know the name of this block one, this block. Okay, let me remove this thing. And this. Okay. The name of this block, the names of this block, both of them, the name of this block, and the name of this block. This will be your inlet, okay? This whole thing
Yes.
is your inlet,
I
okay?
need I need to put the all the points of the vertices in that.
Yes, in inlet, in inlet, okay? Let
Mhm.
me tell you, let me open this thing. Let me stop it. Now, can you see my Ubuntu terminal? Can you see my
Okay.
Ubuntu?
Yes, I
ls
can see.
cd system, okay, ls vam block mesh, okay. In inlet section, you have 4 or 5 different points, okay.
Mhm.
You can see there. This is the only one point, okay.
1 point
Example,
exactly.
in you have 3 or 4 points, okay.
Uh,
First one be like this, and then this, okay. You have enter up 4 points here. Then you will enter once again 4 point here, okay. And like this, you have enter 2 or 3 or 4 point, okay.
okay, I understand.
Okay, now let me stop this thing and go back to your whiteboard once again. Share whiteboard, okay. Okay, this will be our inlet. And what about our upper wall? Our upper wall will be like uh, one second. This is a yellow, and this will be our
Upper.
upper wall. Okay. How many points we have? Point number one,
Mhm. One,
two,
two, and three.
and three. Okay.
Mhm.
These are the three vertices. Okay. This will be our outlet. Let me just do thing here. This is our outlet.
Mhm.
So the points are which are 1, 2, 3,
And
and
four.
4. Okay. You have also them in a Z direction. Okay. I'm not just writing here. So you have to also assign them in a Z direction. But right now I'm just simply giving you have 4 and 4 in that direction. You have total 8 points. Okay.
Mhm. Okay.
Like in uh, lower wall, this will be my lower wall. So the lower wall is the only thing which we have only 2 points and 4 vertices. Okay. Okay.
Mhm.
So this
Okay.
is our lower one. So what about this square one? This square one, I have this point number one, point number two, point number three, and point number four. By putting them in a wall, you can define it as a square. Okay.
That is a square. But okay.
Okay.
Yes.
Okay. Up till now, if you have any question, you can ask me.
My question will be that this is wait. This
So
is
you
the font. Sorry, this is the upper and lower. This this thing is not could considered as upper, and also this not considered as a lower.
no, you can just give them simply all of them in a simple one form. Okay. You can define all these 4 vertices in a symbol. You can give another name. Let me open block mesh for you and stop this thing. Okay. Now let me share from here. Share screen. Share. Okay. Now can you see my Ubuntu terminal?
Yes, yes, I can see.
Now you can define here a new thing. Okay. Like this and enter. You can write here square, 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 space,
Mhm.
enter. This curly bracket, enter. You can write here type wall, okay, space. Then you can write faces, enter.
Okay.
And you can like write this, enter. Then you define here block. Then you can close it with the semicolon. Okay. After this one, then you can enter and enter once again your curly bracket. Okay. So this will be like this. You can define 4 point hairs, and like this you have your stair wall. Okay.
Okay, okay, I understand.
Great. Okay. I think you have understand what I am saying. Okay.
Yes, yes, yes.
Okay. So if you have any more question, you can ask me unless we can leave.
No, I believe that is considered what as a solid. So that's right. The
Okay,
square is considered like a solid, maybe, or I am not correct.
so you understand it.
No, like I said, is that no. This is the continuing, and also the square is considered like a solid.
So
That's correct.
you so you want simulation inside this block or outside this block?
Inside.
If you want simulation inside, then you have to create another mesh. This is empty from inside, but it is a solid. Okay, this block
Mhm.
is a solid. We can define here it as a wall, but this is empty. You cannot perform any simulation inside. In it, you can perform simulation out. Let me just share from here and whiteboard here. Okay, let me remove something from here. It is okay. So this is like clear all drawing. Now this is like this. You have this is your domain. Okay,
Mhm.
and this is your object, which name is this. It is in a red color. It is placed at uh, okay. This is your object. Your object is placed here. Okay, like this. Okay. Now your flow will enter from this thing. This is your inlet. Okay, like this,
Mhm.
and it
Yes.
will go in and strike this.
Mhm.
Okay, and strike this, like go this, but it is empty from inside. There will be no any simulation at inside. Your
Yes.
all
Yes. Yes.
simulation will be outlet, and your fluid will be like this, like strike this and
Uh-huh.
go
Uh-huh.
there and go there. So this is
Yes. Yes.
mesh for in this case. And if you want to do simulation inside a box, then you no need anything of this kind, and you can remove all these things. You can just create a simple block. Okay, so
Mhm.
this is your scare. You, if you want simulation inside it, then give boundary condition this thing, and this will be your boundary condition. This is your, then this will be your inlet. Okay, this is
Um,
your inlet. This is your
uh-huh.
upper wall. This is your
Yes.
lower
Yes.
wall, and this is your outlet. Okay, that is the case of the scare. Okay.
Okay. Okay. If the maybe what it if the I don't have the maybe this is the when it's composed about a square or rectangle. If I have that thing, for example,
Okay, you can
maybe.
also, yes, you can also write this in the form of different patches or a different blocks. You can write simple blocks. Okay, like we have assigned in your boundary mesh, we can assign different blocks. For example, this is the block. First, we define like this. Okay, so you have removed like this. Okay, this is our block number one. Then we can assign another block from this to this. Okay,
Mhm.
then we can assign in the form of like this, like this. You can assign every block which want, which whatever want you like in 2D. Okay,
Okay, and then also the upper is that
sorry, I'm not understanding what you're saying.
that I writing is or that I drawing is lower upper um, the uppercase upper
This is the
also
boundary condition, not uppercase. This is the upper wall boundary condition, and this is the
yeah,
lower
upper
wall
one.
boundary condition. Okay.
Mhm. Okay, okay. I will also I put the all the vertices, right? This is
Sorry,
the
sorry.
first vertex. This is the first vertex, second, third, four,
Yes, yes,
five.
yes, 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 yes. You have to define these point vertices. This is vertex number one, vertex number two, vertex number three, vertex number four, vertex number five, vertex number six, vertical number seven, eight, and nine. Okay.
Ah, okay, okay.
I think you have understand in a good way.
Yes, yes, yes. I understand it.
Okay. So tomorrow, you will give me how we can write a boundary condition, the mesh which you have. Okay, so you have to write boundary conditions of your mesh. Okay.
Yes, but I will find the structure of the of that for boundary condition because I
I
don't.
can share this video with you on my YouTube channel. Okay.
Please, I can appreciate it.
Okay, good. Now I can share it after stopping. It will be automatically saved in my PC. Then I can share on my YouTube channel. You can access from it. Okay.
Okay, sorry. Well, it is possible to tomorrow start at the same hour
Okay. Well, no
that today.
issue. Okay. Okay. So we can tomorrow. We can also have same class at 7 p.m. at my time and 9 a.m. at your time. Okay.
Yes, yes, please, because Friday and Saturday I have to teach at the university.
Okay. Okay. No issue. No issue, Joseph. We can. So tomorrow we have class at 9 a.m. Okay.
Thanks a lot, Walid.
Thank you. Bye bye. But if you
See you
have still any
tomorrow.
question, you can ask me right now.
No, no, I don't have problem. For me, it's okay. I want to practice with the video for incorporate the boundary condition.
Okay, okay. Then bye bye. Take care.
Bye bye. See
Bye
you. See you tomorrow.
bye. See you.